Magnetism is one of the most interesting topics in physics, and in today's video we will learn about magnetic moment and how magnetic moment is responsible for the origin of magnetism in certain materials. If you are a BSc or MSc Physics student, you will find this particular video very helpful. Okay, so what is magnetic moment or magnetic dipole moment? Magnetic moment or magnetic dipole moment is a vector quantity that represents the strength and orientation of a magnetic source. Okay, strength and direction or orientation of a magnetic source. It determines how strongly a material or a particle interacts with an external magnetic field. We will see this particular point, we will explain this particular point in a while. So it also determines how strongly a material or a particle interacts with an external magnetic field. So there are mainly two types of magnetic moments. What are those? Those are orbital magnetic moment, which is caused by the orbital motion of an electron around the nucleus, and another one is the spin magnetic moment, which is caused by the intrinsic spin of electrons. Okay, so this is the motion of an electron, this is the nucleus of an atom, here is an electron, so the electron moves in an orbital motion like in this particular orbit, and the electron also spins around its own axis while in orbital motion. So the electron has basically two types of motion. Okay, mathematically how will you express this magnetic dipole moment? Okay, so this mu vector is magnetic moment or dipole moment, I is the current, or A is the area vector of a loop. Suppose we may consider I may draw pen. Suppose we consider a current carrying loop. Okay, so and a current is passing, suppose the current is I. So A is the area of the loop, which is nothing but the pi r square, r being the radius of this loop, I is the current, and then we can calculate the magnetic dipole moment. And for an electron, the magnetic dipole moment is given with this expression: mu is equal to minus g mu b s. Okay, what are these various quantities? Mu b is Bohr magneton, g is g factor, and s is the spin vector. Okay, what is g factor? G factor means the splitting of the energy levels of an atom in the presence of an external magnetic field. Okay, so Bohr magneton. So Bohr magneton we just introduced in the earlier slide. So what is Bohr magneton? Bohr magneton is a constant. Actually, it's a constant that represents the magnitude of magnetic moment. Okay, magnitude of magnetic moment. It's a constant, so it certainly gives a magnitude of an electron due to its orbital or spin angular momentum. It serves as natural unit for expressing the magnetic moment of electrons. Okay, so basically if we have to measure the magnetic moment of an electron, the Bohr magneton serves as the unit for magnetic moment of electrons. Okay, so this is the calculation for Bohr magneton. So Bohr magneton has it is expressed by this particular expression. So if I can remove just okay, let me remove all these marks. Okay, so Bohr magneton is mu b equal to E h cross by 2 me. What are these various quantities? E is, the charge of an electron, 1.602 multiplied by 10 to the power minus 19 coulomb. H cross is nothing but reduced Planck's constant, having this value. M is the mass of an electron, having this particular value. So then you can calculate mu b. Okay, we have all the values here. So what is mu b? Mu b will give you the value of Bohr magneton, and I want you to calculate the value of Bohr magneton, and that particular value you can write in the comment section. I am leaving that for your own calculation. So I hope you have understood Bohr magneton now. It's a constant and represents the magnetic moment of an electron due to its orbital or spin motion. Okay, it serves as a unit for magnetic moment. So this is Bohr magneton. Okay, now how can you visualize a magnetic dipole? So a magnetic dipole can be visualized as a bar magnet which has both north and south pole. I'll show you. The field lines emerge from north and enter the south, resembling the field around a tiny current loop. Okay, this system behaves like a magnetic dipole with the dipole moment pointing from south to north pole inside the magnet. So a magnetic dipole may be visualized. So stop the video here for a few seconds, read what have been written in the points, and now let us check this picture. This is like a magnetic dipole moment. A magnetic dipole moment is like a bar magnet. Okay, it's like a bar magnet having north pole and a south pole. So the magnetic field lines emanate or emerge from the north pole and they enter the south pole. Okay, so we can visualize a magnetic dipole moment like a bar magnet as shown in this particular picture. Okay, so now the question is, what role does magnetic dipole moment play in magnetism? It plays a very important role. Okay, we can say that magnetic dipole moment is the source of magnetism. In atoms, magnetism arises due to unpaired electrons. Okay, unpaired electrons, we'll discuss in detail about magnetism in materials in our future videos. So it arises due to unpaired electrons. The magnetic moment of these unpaired electrons, okay, remember the magnetic moments of the unpaired electrons, if they align, okay, if align means they align along the direction of the external magnetic field, they create a net magnetic dipole moment or a net magnetic field. Okay, a magnetic moment, let me show you here. A magnetic moment is generally represented by an arrow, okay, like this. So let me draw a few, 1, 2 or 3, okay, 3 magnetic dipoles. Let me draw. They have, suppose you have applied a magnetic field like this, okay, H vector. So all of these magnetic dipoles have aligned. That means they will give rise to a net magnetic moment or a net magnetic field. Okay, and they may be randomly oriented. This is one magnetic dipole, this is one magnetic dipole, this is another magnetic dipole, this is another magnetic dipole. So the net magnetization in this case will be very low or almost equal to 0, or we can say that this particular sample is not magnetized. But if they align along the direction of magnetic field, then this particular material is strongly magnetized. So there is also another concept of magnetic domains. I think about magnetic domains I will discuss in another video, but because this itself is a significant topic to discuss. Okay, but for now you just learn that in materials a group of atoms with aligned magnetic moments. Okay, in materials, group of atoms with aligned magnetic moments form magnetic domains. So in a magnetic domain there are several magnetic moments, and if these domains align over large regions, the material becomes magnetized. Okay, this thing I will discuss in a future video, because if I have to discuss it now, then today's video will become longer. Okay, now types of magnetic materials based on magnetic moment behavior, very important. Diamagnetic materials. How many types of magnetic materials? About that also I will make a dedicated video, but here I am going to give very brief description about different types of magnetic materials we may have based on magnetic moments. Okay, diamagnetic materials, they don't have permanent magnetic moment and they are repulsed by magnetic fields. Paramagnetic materials, unpaired electrons are there with magnetic moments, but they align weakly with external fields. Okay, ferromagnetic materials are very strongly magnetized, strong alignment of magnetic moments we can observe, and even when they are aligned, when the external magnetic field is withdrawn, for example iron. Okay, and then anti-ferromagnetic materials, magnetic moments align, but they align in opposite directions, so they cancel out. Why cancel out? Because magnetic moments are vectors, and vectors are, I mean the net, if you add two vectors and if they are oppositely directed, they are equal in magnitude and oppositely directed, then the resultant of those two vectors will be 0, so they cancel out. And another is ferrimagnetic material. They also have opposite alignment, but they are unequal in magnitude, therefore there is some sort of magnetism in ferrimagnetic materials. So these are 5 different types of magnetic materials: diamagnetic, paramagnetic, ferromagnetic, anti-ferromagnetic and ferrimagnetic. We will discuss about them in another video in future. So for your understanding, these are paramagnetic materials. See, magnetic dipoles are randomly oriented. Anti-ferromagnetic, okay, let me discuss ferromagnetic. Ferromagnetic, see, all the magnetic moments are aligned. Okay, all are aligned along the direction of magnetic field. If this is the direction of magnetic field, they are aligned, and therefore they have very huge magnetization and they are strongly magnetic. Then comes anti-ferromagnetic. See, magnetic dipole moments are oppositely directed. They are equal in magnitude but oppositely directed, so the net magnetization is 0 here. Ferrimagnetic materials, they have magnetic moments which are unequal in magnitude, but they are oppositely directed, so they have some amount of magnetism. Okay, we have discussed this in the, they have some or partial amount of magnetism, which we have already discussed briefly. So quickly you can stop the video here and you see how the magnetic moments align in different types of magnetic materials: paramagnetic, ferromagnetic, anti-ferromagnetic, and ferrimagnetic. Okay, so in conclusion, the magnetic moment is the fundamental building block of magnetism. We have already discussed. Whether in a single atom or in entire material, if the alignment and behavior of magnetic moments that dictate how something becomes magnetized and interacts with magnetic field. So it is the behavior of these magnetic moments, how they align, so that will determine to what extent a material is magnetic. Okay, if it gets magnetized or not, and whether and how it interacts with magnetic field, if gets aligned in the direction of magnetic field or not, those things will be determined by nothing but the magnetic moments. Understanding magnetic moment is very crucial for designing magnets, magnetic storage devices, and various other electromagnetic technologies. So friends, this was all about today's discussion. We have discussed about magnetic moments and why magnetic moment is important and how they are related to origin of magnetism and various types of magnetic materials. So if you have liked the video, please like it, share the video, and if you have not yet subscribed to the channel, please subscribe to it. Very soon I will publish another such informative video. Thank you very much.